Hi everybody, welcome back to my channel Concept Learning. This is Rasagna. Hope you all are safe amidst this COVID-19. So what did we do in our last class? We have introduced ourselves to multiple integrals as well as double integrals, and we have also done a very basic problem on double integrals. And today I have told you that in my next class I am going to go much deeper into double integrals, right? So yeah, let's get started with it, okay? Okay, so in this class we are going to go deeper into double integrals, and I also told you about what are we going to deal with. Uh, in last class we have dealt with the sum in which both limits are given and we have evaluated the value of it, right? Yes. So, but in this class what we are going to do is you're not going to be given any limits over there, but you have to find the limits by yourself, right? Yes. So we'll deal with that topic with a example problem. This is a problem and we'll understand through this problem very quickly. Okay? Yes. So let's get started. Um, what is the sum? Evaluate integral xy dy dx where a is the domain bounded by these curves. Okay, so these are the curves given, and we have to find out, we have to evaluate the value of this within this bounded region by these lines. Okay, yes. So let us look at this problem. We have the problem as double integral a xy dy dx. So this is the problem, and he have given us these three curves and we have to find the limits through these three curves. Okay, and how do we find it? That is what we are going. This is the y-axis and this is the x-axis, as you all know, right? Yeah, so x-axis and y-axis respectively. Now, we have curves x-axis. So this is x-axis, that is y is equals to 0. That is one curve. And the next one is x is equals to 2a. X is equals to 2a. That means it is parallel to y-axis. So that will be somewhere around here. So this will be the line x is equals to 2a. And the next curve is x square equals to 4ay, and x square is equals to 4ay is a parabola, as you can see, and and that parabola cuts this line also. And where does it cut? We'll just look at it. X is equals to 2a, right? So 2a square is equals to 4ay, and 4a square equals to 4ay. So y is equals to a, right? So at x is equals to 2a, y is equals to a, right? Yes. So a will be somewhere around here. So this point will be 2a comma a. 2a comma a. That is it. So that's the point, and through that point our required parabola passes through. So let us draw it now. Something like this. Okay. Yes. So what is the area that is bounded by the three given curves? The three given curves are y is equals to 0, x is equals to 2a, and x square equals to 4ay. So the required bounded region will be this. Right? That is it. So that is the region. And now how do we find the limits from this? To find the limits from this, we have to first take a strip in that area. And he didn't give us any strip over here and didn't give any conditions over here. So the strip, you can take it either parallel to the y-axis or parallel to the x-axis, but you have to take any one way. So choose any one way. Okay, let me take line parallel to y-axis. Okay, I will take the line parallel to y-axis. Oh, done. So that is the strip that I chose. This is the strip that I chose. Okay, that is parallel to y-axis. Now through this trick, I have to find out the limits. By looking at the three curves where they are cutting and where the area is bounded, I have to find the limits. And how do you do that? Now this is the strip that we took, and how is the value of how is the value, that is the limits, varying according to this strip on x-axis. If this is the x-axis, okay, and according to x-axis, how are the limits varying? That is, from where to where is the strip moving? If we move from here to here and you compare it with x-axis, on x-axis, according to x-axis, with respect to x-axis, this strip moves from 0 to, this is 2a, okay. So that strip moves from 0 to 2a. So the limits with respect to x will be 0 to 2a, okay. So if I write this same thing out here, then this will be this will be integral of 0 to 2a xy dy dx. This is common, and I have now found out the limits with respect to x. So x is equals to 0 and x is equals to 2a. That is what I have found out. Now I have to find out with respect to y. With respect to y. So now how will I do that? How is the strip varying with respect to y? That is what we have to check. Now this is the strip, and this strip varies from here to here with respect to y. With respect to x, we have seen it varies like this on the x-axis, but in this it is varying according to the curve. So we need to take the value of y with respect to the curve, okay. So if the curve, so the curve here is x square equals to 4ay, and the strip is moving on the curve with respect to y-axis. So y is equals to x square by 4a, and it starts from 0, 0 to 4a, 0 to x square by 4a, because this is the curve now. So the strip is moving on the curve, okay. So the limits of y will be, I'll write it far away. So y is equals to 0 to y is equals to x square by 4a. So these are the required limits. Now did you all understand how we have found out the limits according to the, that is with the help of the curves? I'll tell you once again. You have to first take a strip. So it's your wish, you may take it parallel to x-axis or parallel to y-axis, and here I took it parallel to y-axis, okay, and I have to see how the strip is moving, okay, with respect to x and with respect to y. When I check it with respect to x, I'll get the x limits, and when I check it with respect to y, I'll get the y limits. So if this strip is moving with respect to x-axis, I can say that it's moving from 0 to 2a, and with respect to y-axis, it is moving on the curve. So y is equals to x square by 4a, and those are the limits, okay. Okay, so after that you can easily solve the sum. We have 0 to x square by 4a and 0 to x by dy dx, and here the variable limit is f is with respect to x. So first you have to differentiate with respect to y, that is with respect to dy, and I'm sorry, with respect to y, and then we evaluate it completely, okay. So now integral of 0 to 2a respect to y, right? So x into y dy integral of 0 to x square by 4a. Okay. Now I may rub this diagram. I will erase this. Okay. So with this, what do I get? Integral of 0 to 2a x into y square by 2 into 0 to x square by 4 dx. Okay. So that implies x is equals to 0 to a x power 4. So x power 5 by 260 16 a square. That implies 0 to a x power. Okay, I'll integrate it. X power 6 by 6 0 to a 1 by 32 a square. Okay. So x power 6, that is 2a. If I put 0 anyway, it will become 0. And if I put 2a, I will get 64 a power 6. Okay, I'll write it directly. Power 6 into a power 6 by 6 into 1 by 32 a square. Okay. Yes. So this is 2 power 5 and 1 2 will be left over here. So that will become, that implies this will become uh, 2 into a power, this is square, right? So a power 4 by 6, that implies a power 4 by 3. Okay. So that is the final answer. Now what is the thing that you must do is you have to take the strip which is parallel to x-axis and do the same way, follow the same procedure that we have followed now and check it. So to make it simple for you, I'll once draw the diagram and show it for you, and then you can do it much clearly. So if this is the, these are the axis, okay, this is x-axis and this is the y-axis. So I'll draw the curves also for you. This is x is equals to y is equals to 0, that is x-axis, and you have x is equals to 2a and some point 2a comma a and parabola which passes through this point. Okay, so this is the area that we want, and now you have to take a strip parallel to x-axis. So you are going to take this strip parallel to x-axis, and how is it moving with respect to x-axis? So how is it moving? If you see this strip with respect to x-axis, it moves like this. So that is on the curve. So now what you will do is you are going to write the limits of x as 0 to, start from 0 and lies on the curve. So 0 to root of 4a by x is equals to, and with respect to y on y-axis, how is it moving? From 0 to a. Okay, 0 to a. And xy dy dx. So these are the limits, and you solve that problem, and you will find that the answer over here, and if we take the strip parallel to y-axis that we did before, will be the same. There will be no difference in that. So to get much clarity, you have to keep solving more problems, and then you will be getting much experience and you will understand much better. So we'll also do another sum. Okay, let's see. Okay, so now let's look into this sum. This sum is integral of that is r x square dx dy. Okay, this is the sum. And now what are we going to do? In the same way, once again we are going to, we have the curves over here, right? So we have to draw them, represent them on the Cartesian plane. Okay, so let me draw the axis first. This is x-axis, x-axis, and this is y-axis. So now what are the curves given? Let us see. X is equals to y is equals to 0. Okay. So first let us look at x is equals to y. So x is equals to y means that will be like this. Okay, sorry. That will be passing through the horizon, as you all know. This is the curve x. Okay, x is equals to y. Okay, and now the next one is y is equals to 0. That is the x-axis. Y is equals to 0. and next one is x is equals to 8, and x is equals to 8 is parallel to y-axis. So we have to see where does it meet x is equals to y. Because this curve is x is equals to y, that definitely meets at a point 8 comma 8, right? So let this point be 8 comma 8, and then this line will be x is equals to 8. Okay, that is it. And the next curve is xy equals to 16. So if you look at it, it is a rectangular hyperbola, and how would it be? It will be something like this and like this, and we'll draw it after knowing where the curves meet. Here xy is equals to 16. So where does this meet? X is equals to 8. 8 into y equals to 16, and 2 y is equals to 2. So the point will be 8 comma 2, and it will be somewhere around here. 8 comma 2. Okay, 8 comma 2. That passes through this, and x is equals to y, where x is equals to y. So let me put that also there. So y square equals to 16, and y will be 4. If this is 8 comma 8, and 4 comma 4 will be somewhere around here. 4 comma 4. Okay. So then how will this be? This is the x-axis continuing. This will not touch the axis, if you remember. Okay. Sorry. Something like this without touching the axis, and another curve will be like this. Here you got it is not 4 plus or minus 4. So plus 4 comma plus 4 and minus 4 comma minus 4 is another one, but we have already given you that R is the region in first quadrant. So we are going to consider only here, not in this. We don't need to draw any asymptote over here. Sorry, that is high rectangular hyperbola over here. Leave this. We have to look at only this. Now, what is the region that is bounded by all the four curves commonly? So, if you look, this is the area. Look at it. I will draw it with this. The area is this itself. So that is the area, required area. Okay. So now we have to take a strip and move it, and then we'll get to know where the limits are. Understand? But now here arises a very small problem. That is, if you look here, we have a sharp end, and there the area varies because the upper curve is different for this part, and the upper curve is different for this part. Okay, so the two curves are different. And now what are we going to do? So for that case, what we are going to do is we are just going to divide that area into two parts. So here we will be dividing it into two parts. Okay. So now the same way take the strips, but we are going to take the strips here and here. Okay, to solve. So this will be one strip that is moving in this area, and this will be another strip moving in this area. I am taking the strips parallel to y-axis once again. Okay, you may also do it taking parallel to x-axis. Okay. And now what will this become? Now let me think that the required answer be I. So I is equals to integral of. So I'll be getting two parts. Okay. So at first xy dy dx, at first the limits of uh, how is the strip varying with respect to x-axis, and now what is this point 4 comma 0, right? Yes, so this is 0. So with respect to x-axis, that is moving from 0 to 4. Okay, 0 to 4, x is equals to 0 to x is equals to 4. Okay. Now with respect to y, it is moving on this curve, x is equals to y. So 0 to x, y is equals to 0 to y is equals to x. Okay. So that is it. So plus that is this part, that is this part, and that is this And now we have to look into the second part also. And now what are we going to do in the second part? How is this varying? Uh, with respect to x-axis, the strip is varying from 0 to, this is 8 comma 0. So 4 to 8. Okay. Plus integral of x is equals to 4 to x is equals to 8. And with respect to y-axis now. So with respect to y-axis, this is moving on this curve. Okay. So that also, from that curve, how is it moving? So the strip is moves from here to here. So at this line, that line, what will this line be? If I draw a line here, what will this line be? X is equals to 4, and x is equals to 4. That line would be, and at that line y is 0, right? So the limit starts from 0. At that line y limit is 0. So 0 to moves on this curve, right? So on this curve, y is equals to 16 by x. So y is equals to 0 to y is equals to 16 by x, xy. Okay, sorry, not xy, x square. I'm very sorry, x square dy dx. And you have to solve this now. How do you solve? First, you will be solving with respect to x over here, because you have y limit as varying, right? Yes, y limit is varying. So with respect to okay, we have to solve it with respect to y. Integral of 0 to 4. With respect to y, so x square into 1 dy, that is 0 to x dx, right? Plus here also 4 to 8 x square into integral 0 to 16 by x 1 dy dx. Okay. So we are going to solve it. We will be getting x over here. So by 0 to x will be limits. So x will be there, and x cube integral 0 to 4 dx, plus in the same way we have 0 to 8, and you will be having y limits 0 to 16 by x square dx. So this will become 16 by x, right? And the writing directly 16 by x, and this will cancel. And now I erase this diagram. And now what we will get? X power 4 by 4 into 0 to 4 plus this is 16x. So 16 into x square by 2 into 4 to, okay, this is 4. 4 to 8. Okay. Okay. So now 4 power 4, 4 power 4 by 4 plus this will cancel with 8, and 64 minus 60. Okay. So 4 cube is 4 4 16, 64 plus 64 minus 16 is 8, and by 48. Okay. So that would be your final answer. Okay. So that is it for today. In our next class, we are going to look into changing the order of integration. Okay. So that's all for today. Meet you in my next class, and do not forget to like and share the video. Also subscribe to the channel for more videos of multiple integrals. Thank you for now. Meet you in my next class. Bye bye.